In this next tutorial, we'll solve sets of nonlinear equations with Python using the fsolve solver. Now let's just review how to solve equations with fsolve. We're going to start just with a set of linear equations similar to what we did previously with this with using linalg.solve, but in this case, instead of using linalg.solve or inverting the matrix A, we're going to just solve the same problem using fsolve. So if you'd like to follow along on this, here is the address for it, APMonitor.com/CHE263, and then just on the right go to schedule, and this one's going to be homework number 3. You can just click on the Google Colab link, or you can get the GitHub repository. Just go to homework 3, problem number 2. Okay, I'll also post those links in the description in the video below the video. Alright, we have fsolve, this system of equations. One of the things that we have to do with fsolve is just shift everything to one side of the equation and then define these new residuals, f0 and f1, and return those from a function. So I'm going to come here to let's come here to fsolve, and if we do that, we define this new function where we've put everything on one side of the equation, multiplied out this these matrices as a function of x0 and x1, and then it returns the residuals of those values. So I can, instead of using fsolve, I could try to find those solutions myself. I could do print, and then let's just do f of 1, 1, and I can see that the second equation is satisfied, but the first equation is not, and so that has a residual of 3. But if I kept looking for a solution, I could just do guess and check over and over again until I found something that was close. Now this could take a long time for large systems, or maybe for small ones the solution might be obvious. But if I use fsolve instead, I just need to first of all import that from Scipy. So from Scipy optimize, I'm going to just import fsolve, and then I can use that as fsolve, and this is going to be f comma, and I have to give it an initial guess. In this case I'll do 1, 1, and then I'll print a value of x. Okay, so that gave me a solution just like I found previously when I solved it as a set of linear equations. Okay, so those were some initial guesses that we showed, and then we solved it as it instructs us here. So now let's solve this set of equations. We're going to determine a solution for x and y to the following equations. There are 4 possible solutions where these intersect, and so you can see the 2 equations. One is the this first one right here, centered at 0, 0. It's just an ellipse, okay, and then we want to see where the values of x and y are going to satisfy both of these. We have another ellipse that's shifted off to the side, center about right here, and they're going to intersect at some of these gray points. Okay, so let's set up and solve this just like we did before. I'm just going to copy this one, define my new function, and then solve it. So okay, so let's okay, so I'm going to come down here. I'll just do it all in this box right here. But let's go ahead and just modify our function values, what we return from these. I'm going to put everything onto one side of the equation. And so in that case, it's just going to be 2x squared plus y squared, and that is going to be minus 1. Okay, that's going to be our first function. And then the second one, we're just going to take this next equation, 0.5 x minus 0.5, and then I will square that, plus 2 times y minus 0.25 squared minus 1. Okay, those are going to be our two residuals, so it's going to be satisfied when both of those are equal to 0. So we need to create this function down here below that's going to be able to return for different guess values. It's going to be able to return different values, but let's use x and y instead. I'm going to say that I have that as a function of z, and let me make this just a little bit bigger. And then I'm going to split those out in the first line. I'm just going to say x comma y equals z. So z will be consisting of two values, and then I have 2 times x squared plus y squared minus 1. And let's do it for the next one as well. Okay, 0.5 times x minus 0.5, and then I'm going to square that, plus 2 times y minus 0.25, and I'll square that and do minus 1. Okay, and then I'm going to return both of those. And so let's just test that function before we do the fsolve. Okay, and so I'm just going to print f of, and then let's test it for 1 comma 1. Okay, so I can see that those are not equal to 0, so that's not a solution. But let's see if we can get fairly close to one of these. I'm just going to use a value of x of about 0.25 and a value of y of about 0.9. Okay, and then you can see it's getting closer to 0, but it's not quite there yet. Alright, let's go ahead and use fsolve to solve this. I've already imported this, so this one isn't necessary. Again, you only need to do that once per session. And then if you solve it, now you can see the value of x that solves this. So it was 0.29 and 0.91. So we got fairly close just by looking at it graphically. Sometimes you can't even visualize it. You have more than two variables. Okay, so let's see if we can find some of the other solutions as well. I'm just going to put -1 there to start, or -1 here to start. Okay, and then you can go through and try to find, based on where you start from, you can try to find the other solutions. So for example, we just found this one right here. We could use something like Scipy if we want to find all of the solutions, but we'll show that the symbolic Python package later. In this case, the fsolve is just going to return one solution. Okay, so there is problem number 2. We're going to go on next to problem number 3. This is going to be just one equation, one unknown, but just a little bit more complicated for this one. And then the final one that we're going to solve is going to be 3 equations and 3 unknowns. This one's going to be a vapor-liquid equilibrium problem from engineering to determine when you have a mixture of two species, how much is going to be in the vapor and how much is going to be in the liquid phase. Okay, so I hope you enjoyed this tutorial. Feel free to leave a comment down below if you have any questions or further comments. But this is how we do use fsolve to solve equations. You just need to replace this function, the function that's there, with any custom function. You can put any number of equations in there. It can handle hundreds or thousands of equations as well. Okay, we'll go ahead and end it here. I'll post the video on the course website, and stay tuned for additional solutions as well.